Okay, so today we're going to be taking notes on what we call the difference of squares. Before we get started on the difference of squares, want to make sure that you guys understand a couple of things so that we got to kind of lay the groundwork here. First of all, let's talk about what does it mean for something to be a perfect square number. Okay, SQUAR, perfect square number. Okay, so a perfect square number is when you take a number, say like 1, and you multiply it by itself, and then the result that you get when you multiply a number by itself is a perfect square number. So the first perfect square number that exists in the world of numbers is the number 1. If I kept going and I took the next number, 2, and I multiplied it by itself, the result of 2 times 2 is 4. So that tells me that my next perfect square number is 4. When I take 3 and when I multiply 3 by itself, the result is 9. So that tells me that my next perfect square number is 9. And I could keep going and do this all day if I wanted to. And the only thing that would stop me would be like boredom or too much excitement or something like that. So because 4 times 4 is equal to 16, that means that 16 is a perfect square number. So it is a good mathematical practice to have at least, I would say, the first 12 perfect square numbers memorized here. I have given you the first 4. The next ones would be 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. And the list of perfect square numbers just dot, 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 dot. It just keeps going and it really never ends. I mean, you could keep doing it until you don't want to do it anymore. But like I said, it is a good mathematical practice to have at least the first 12 perfect square numbers memorized. Okay, now here is the concept. Today what we're going to do is we're going to learn a rule of a thing called the difference of two squares, and the fact that perfect square numbers are going to apply to this rule here. Okay, but first of all, before we do that, let's lay a little bit of groundwork as we as I go through this here. Okay, so let's say, and this is what we learned last week. So let's say that I tell you to take the quantity x plus 5 and multiply it by the quantity x minus 5. Let's go ahead and do this, and let's see what this equals right here. The quantity x plus 5 times the quantity x minus 5. So we would go x times x, which is x to the second power. Then we would multiply the x times the minus 5. And that gives me a result of minus 5x. So I'm going to write minus 5x. Then we would multiply the positive 5 times the x. What we're doing is we're doing that concept called double distributing. That becomes positive 5x. And then lastly, we would multiply the positive 5 times the minus 5. And that would give me a result of minus 25. And then you could see that when I simplify this, the minus 5x would cancel out the positive 5x. So therefore, we get x to the second power minus 25. Okay, so what we have just found out is that when I take x to the second power minus 25, if I said factor it, remember factor means to take an expression and then find two expressions that would multiply together to equal that expression. Well, the two expressions that multiply together to equal x to the second minus 25 is x plus 5 times x minus 5. Okay, and so what this does is this leads us to a rule right here, which is a rule that is called the difference of squares. And the difference of squares is a rule that it is a special factoring rule. When you run across a certain type of problem that looks like x squared minus 25, where a couple things have to happen. First of all, it has to have a subtraction problem, and the numbers that you see have to be perfect square numbers, okay? So any number, numerical value that you see has to be a perfect square number, okay? So what I'm going to do is I'm going to go over here and I'm going to give you 2 or 3 examples of what we have, what we call the difference of squares, okay? So difference of squares examples, and then we're going to talk about how do you factor difference of squares, okay? And it's going to be a simple difference of squares examples, first of all. All right, I'm jumping ahead, sorry. So here is an example. Let me give you 3 examples of problems that would fall under the category of the difference of squares. First of all, we have to have a subtraction sign, and then any number we see has to be a perfect square number. So x to the second power minus 64. That would be an example of what would fall under the category of a difference of squares. Why? Well, because look, we have a subtraction sign, and then the number that we see, 64, is a perfect square number. Okay, it doesn't always have to have x's. Another example would be, say, y to the second power minus 100. That would be an example, another example of what would fall under the category of a difference of squares. 100 is a perfect square number, and then we have the subtraction symbol, okay? I said 3 examples. Let me give you another one. The perfect square number doesn't always have to come at the end. It could come at the beginning. So if I wrote 81 minus, say, w to the second power, that would be considered a difference of squares. That would fall under the category of a difference of squares. Why? Because 81 is a perfect square number, and we have the subtraction symbol, okay? Another example would be something like this. How about if I say 25 minus, I don't know, let's see, what's one we have? Okay, 9z to the second power. Okay, notice this one right here. Well, 25, all the numbers you see have to be perfect square numbers. 25 and 9 are perfect square numbers, and then we have to have the subtraction sign there. Okay, guys, so that would be kind of the idea. So the first thing that you want to do is you want to recognize a problem that falls under the category of the difference of squares, okay? So now if we go back to x squared minus 25, here is the rule that this difference of squares follows. If you have a problem that falls under the category of a difference of squares, it will factor into, and notice what it factors into. Notice what the 2 quantities that x squared minus 25 factors into. One of the quantities is x plus 5. The other quantity is x minus 5. And this will always follow this pattern for when you're factoring the difference of 2 squares. One of the quantities will have an addition, always. One of the quantities will have a subtraction, always, and then the numbers will be whatever the number is that multiplies by itself to equal the perfect square number that you see in the difference of 2 squares there. Okay, so that would be kind of the idea of how we do this. So let's say that I go, all right, so let's just work on it here, you guys. So let's go ahead and let's say that I say, all right, so I'm going to give you a difference of 2 squares, and what I want you to do is I want you to factor this problem right here. Watch how easy this is. Okay, how about if I give you x squared minus 9, so this will be example 1. We're going to fire through like 6 examples in the next like 4 minutes, and then I think you'll get it here. Okay, so the first thing you say to yourself is, does this fall under the category of a difference of 2 squares? The answer is yes. Okay, why? Because remember, you have to have a subtraction symbol. We got it. And then the number you see, any numbers you see, have to be perfect square numbers. 9 is a perfect square number. So if I said factor this, what would this factor into? Well, here's what you do. You draw 2 parentheses. Whenever you have a difference of 2 squares, one of them is going to have a plus, one of them is going to have a minus, and then the number that you write is whatever the number that multiplies by itself to equal 9, which would be 3 and 3. Okay, and then at the beginning, in front of the addition and subtraction symbol, you write whatever the variable is with no exponents. So x plus 3, x minus 3, that is what the expression x to the second minus 9 would factor into. You're going, wait a second, Mr. Trutna, this seems really easy. Like I don't even have to do any work or anything like that. The answer is yeah, basically you don't have to do any work, okay, you guys? All you got to do is you just have to know the rule. You have to recognize the situation that you have a difference of two squares, and then if you know the rule of what it factors into, boom, you're done. Okay, how about y to the second minus 16? Okay, does that fall under the category of a difference of two squares? The answer is yes. Okay, 16 is a perfect square number, and then we have the subtraction symbol. So what is y to the second minus 16 going to factor into? Once again, how do you do it? Well, you draw two parentheses. One of the parentheses will have an addition symbol. One of them will have a subtraction symbol. This is the rule that a difference of two squares has, okay? You look at the perfect square number, 16, and you say to yourself, what number times itself is 16? It's 4 and 4, so we're going to have a plus 4 and a minus 4. Then in front of the addition and subtraction symbol, you put whatever the variable is without the exponent of 2. So y squared minus 16, when I factor it, becomes y plus 4, y minus 4. Okay, it's that simple. I said we're going to do 6 of these examples. Number 3, let's keep going. Let's do one where the perfect square number is in the front. So how about if I say, what is 100 minus w to the second power? Okay, so let's recognize this. Is 100 minus w to the second power is it a difference of two squares? The answer is yes. Why? Well, 100 is a perfect square number, and we have the subtraction symbol. So how do perfect square numbers factor? Remember, we're factoring. That means that I'm going to find two quantities that would multiply together to equal 100 minus w to the second. So what's the pattern? Well, remember, one of the quantities will have an addition symbol. One of them will have a subtraction symbol. You go to the number, the perfect square number, 100. What times what equals 100? What number times itself equals 100? That'd be a 10 and a 10. But in this case, you put the 10 at the beginning. And the reason why you put the 10 at the beginning is because the number 100 was at the beginning of the difference of two squares. Okay? Then it's going to be 10 plus w, 10 minus w. So the factors for 100 minus w squared are going to be 10 plus w times the quantity 10 minus w. Okay? All right, number 4, 3 down, 2 to go. I told you we're going to fire these out in like 4 minutes. Let's do another one where the number goes in front. Okay, this one's a little bit tricky. This one messes people up. I don't know why, but let's go ahead and do it so it won't mess you up. How about 1 minus z to the second power? Okay, does 1 minus z to the second power fall under the category of a difference of squares? The answer is yes. So then we factor it using the rule of the difference of squares. So what's the rule? We draw two parentheses. One of the quantities will have an addition symbol. One of them will have a subtraction symbol. You go back to the number, the perfect square number, which is a 1. What number times itself equals 1? That'd be 1 times 1. So I'm going to have a 1 starting in each quantity. Then, since my variable is a z to the second, my factors are going to be 1 plus z, 1 minus z. Okay, so the expression 1 minus z to the second power would factor into 1 plus z times the quantity 1 plus z times the quantity 1 minus z. Okay, number 5. Let's do a difference of two squares where we have numbers and perfect square numbers in both parts of the problem. And what I mean by that is 25 x to the second power minus 36. Okay, so let's look at this. Does 25x to the second power minus 36, does that fall under the category of a difference of two squares? We've got the subtraction symbol. 25 is a perfect square number, so is 36. So the answer is yes. So what is the rule? How do you factor a difference of two squares? Well, remember, you draw two quantities, two sets of parentheses. One of the parentheses will have an addition symbol. One of the parentheses will have a subtraction symbol. And now we got to be a little bit careful on this. Let's go to the 36. What's 36 going to become? Well, that would be plus 6 and minus 6. Okay, and I'm writing the sixes at the end after the addition and subtraction symbol because the perfect square number 36 came at the end. But let's go to the beginning. I have a 25, so that means I'm going to have a 5 and a 5 because 5 times 5 is 25. But then I have the x squared, so I'm going to have a 5x plus 6 and a 5x minus 6. Okay, I'm just following the rule that happens when I have a difference of two squares. So the expression 25x squared minus 36, when I factor it, would factor into quantity 5x plus 6 times quantity 5x minus 6. Number 6. Last one. 144. Y to the second power minus 121. Does that fall under the rule of a difference of two squares? Okay, well, let's see. We have our subtraction sign. We have to have that to have a difference of two squares. Is 144 a perfect square number? The answer is yes. 12 times 12, 144. How about 121? Is that a perfect square number? Yes. 11 times 11 is 121. 12 times 12, 144. 11 times 11, 121. So I follow the rule to factor a difference of two squares. Draw two quantities. One quantity is going to have an addition. The other quantity is going to have a subtraction symbol in it. Oops, I messed up. I got to erase. Sorry. It's going to have a subtraction symbol right there. Okay. 12 times 12 is going to give me 144. So I'm going to start each quantity off with a 12y and a 12y. Okay, I'm following the rule. And then I'm going to end it with, since 121 is 11 times 11, I'm going to end it with plus 11 minus 11. So 12y plus 11 times the quantity 12y minus 11 would give me, would be the factors, that would be the two expressions that multiply together to make the given expression 144 y to the second minus 121. There we go, you guys. This is a good, solid, so we have 6, heck, we have like 7 examples of the difference of two squares and how to go about factoring them. That's all.